So like I mentioned, Python has a lot of things like built-in functions, right? So think about functions in this way. It's instructions that the interpreter can execute. Because Python is a high-level programming language, it uses an interpreter to execute the functions. So in this case, if we were to input this following text here, we're going to use the print function and then put in the parenthesis here, right? With the quotes, ICS, the string ICS 101. This is going to have an output value of just printing ICS 101. It's not that much effort, right? You just say print ICS 101 and you get the output value ICS 101, right? I'm showing you the print function. In other cases, we can take, if the function that we want or the analysis we want to perform is not built into Python, we can define a function and write a block of code that performs a single action, right? In this particular case, we're going to put the DEF to say, oh, we're going to define something, right? We're going to define and our function name. And that way you can define a function. For those of you wondering what that really does is, this is similar to think of it as the idea of you have a function in Excel, but it's a custom function where you can define exactly what it does. The next general principle I want you to have a basic understanding of is the idea of a variable, which is a container that can hold information that you can reference later. So if you define it the same way you define a function, where you go DEF and variable name. But one thing you need to understand about a variable is it's kind of cool, because this is the same, basically the same idea as a cell in Excel, right? Like in cell A1, you can hold a letter, right? You can hold a number, right? You can put a function in there, and you can always reference it when you say equals A1. So you can always call that particular variable. So it's pretty cool where you can put that there, where once you define it, you define a variable in your program, you can always refer to it. But it's the same idea as Excel using cells. And lastly, we have what we call parameters. Parameters are basically variables that specify behaviors for a function. So you would do this by typing in, DEF function name, right? And we put in the parenthesis here, the parameters that we want to have. I think of parameters as very similar to the arguments list in Excel, where you put in what it needs to actually do in this particular case. And in Excel, it's a slight difference where you put in what information needs to perform that action. So it's kind of it's a similar idea, but not quite the same. But it's used in a very similar way, which is what I want you to take away. So these major principles, we talk about these 4 major principles, right? Built-in functions, defining a function, variables, and parameters are things that you have experienced with Excel to a good extent. So we're going to take that knowledge. That's why I said, get your Wheaties in you, right? Think hard about these things, right? Get your thinking hats on. Where we're going to take a lot of these things we learned and we're going to apply it to something else. And this is really the whole high-level learning. We're saying, can we take things that have a similar core foundation and apply it in other areas? And I think we all can here. Okay. So now let's go back in time just a little bit and look at some of the historical things we did in class, because we're going to be applying this to our program we're going to be building together. So do you all remember the security lecture from a few weeks ago where we talked about the transposition cipher, right? In this particular case, we said, okay, so if we have a transposition of +2, right, what is the A equal to? A C, right? Because it went 2 to the right, +2, right? So A plus 2 would be A to B to C. In this case, when we did a +2, we could encrypt this word aged beef to CIGF DGGH, right? So pretty simple structure, right? In terms of actually saying, how do we encode and decode this particular message? But remember, I said, this is not that secure since it's 25 possible keys. Well, the thing about it is, it's not that secure, but it still takes time for people to, by hand, recalculate everything. If you want to say, okay, this was a +2 for everything, it's pretty fast. But if I said, well, it was plus like 18, it would take you a while to do that for every single letter, right? Unless you drew it out and then remapped it that way. So it does take a bit of work by hand, a little bit of elbow grease, but it's not that hard. It just takes time. So what I want us to look at was, how can we look at this and actually do it faster with basically a very small program we can write with the knowledge that we gain from this. So we know how a transposition cipher or a Caesar cipher works. By looking at this, we know how it works in the back of our mind, right? So that's how we think computationally. We can say, okay, I know what +2 is, +4, or whatever it is. And I say, well, I want to turn this into this, aged beef into this. I say, okay, +2 on each letter. So I take a letter +2, take a letter +2, and I do it for every single letter. But now let's take a look at the idea of computational thinking. So we know how a Caesar cipher works, but the question is, does the computer understand the way we see a Caesar cipher? right? And the short answer is it doesn't really understand it. So we have to think about how does a computer see things and how do we write things in a way that a computer can understand it. That's how we have to express our thought process in computer-based steps, not in how we do it, but in how a computer can easily read it and understand it and be very discrete, where it's going to do exactly what we tell it to do, okay? So let's think about this transposition cipher in human terms, in terms of how we think about transposing, because in our mind, we just say, okay, +2, add 2 to each letter and done kind of a thing. So let's break that down. So how do we decrypt a message with a transposition cipher? Well, let's go down the list. We select the letter, right? We take the first letter, for example. We adjust by the transposition amount. We said +2. And so we're from A to C, which gets us the transposed letter. And then we repeat our steps with all letters. When we're done with that, we just show all of our adjusted letters and we're done. Makes perfect sense, right, everyone? When you do that, you say, okay, well, we can get our message by doing that for each letter. That's why I have to go through every letter we have in our message to do it. So you say, okay, pretty cool. Not that bad, but can a computer understand these steps?